It's time for us to enjoy the Bonine backyard. Again, you guys said you wanted to come outside to learn a lesson? Well, we're outside. We have the lovely plants and flowers, and we also get the birds chirping in the background. So stay awake there, guys. We're going to do example 4. Now, I need to tell you, this is the most difficult case for an SSA. It's going to give us 2 possible triangles that could come out of this situation. So I need you to sit up straight. That's right. I hope you're sitting in a nice comfy chair, up straight, and you're ready to go. So we're going to draw this possible triangle here. I'm trying to show you from the last example, okay? If this was the height, then I know that this side has got to be longer than the height. Because if this is 11.4, what if it swings out? Or what if it swings in? I tried to draw both scenarios so you could get a feel for what it might look like from a geometry standpoint. Let's take a look at setting up the first case triangle, and then I'll explain the best I can when we get to the situation that turns into number 2. So I take my B and I write it in, and across from it is angle B, which I don't know. And then I take side A and I write sine of 58 degrees, and I put the length directly across from it, 11.4. I'm going to cross multiply, divide, and I'll punch this in my calculator. The inverse sine, because I'm trying to find the angle, of 12.8 times the sine of 58 degrees, all divided by 11.4. And I end up with 72.2 degrees. Now here's the dilemma. 72.2 degrees is acute, and it's in quadrant 1, where all of our 6 trig functions are positive. But sine is also positive in quadrant 2. So if I put this 72.2 degrees as the reference angle in quadrant 2, I'll notice that the angle created there is 107.8 degrees. So if I'm getting the sine's answer at this location in quadrant 1 with 72.2 degrees, I'm also getting that same answer in quadrant 2. Hence why if I just take 180 and I subtract 72.2 degrees, it backs up into the position of 107.8. You can ignore the top right now, okay? So my second triangle is coming from the possibility of 107.8 degrees. When I take 180 and subtract 58, the given angle A, and I subtract 107.8 from angle B, I'll get 14.2 for angle C, okay? I'm looking at this picture where B is obtuse and C would be right there, tiny, little bitty angle, degrees. When I set up the last side C, I set up my proportions, 11.4 over the sine of 58 degrees equals C over the sine of 14.2. I cross multiply, I get little c to be 3.3. Now to make sure everybody really gets this, this is a bazinga moment, I need to go right 3.3, then the next side length would be 11.4, then the largest side length would be 12.8. I'm checking my logic here. I'm going to go to the smallest angle, which better be C, because if C is the shortest side, the smallest angle has to be directly opposite from it. So 12.8, what side was that? B. Is B the largest angle? Yes, it is. All right, wake up there. No sleeping. So here we go. Side A, angle A. Side B, angle B. Side C, angle C. Actually, sorry, I had the letters backwards, but they go in ascending order. So now you're saying, why is this one so tough? Because we're not done. Sorry. Okay. Stand up if you have to and take your notes. All right, here we go. The other triangle, triangle 1, is coming from given information. 58 degrees, that's what I was given, okay? The 72.2 degrees that I found right there. And I had 11.4 for side A and 12.8. So if I take these two angles and add them up and subtract from 180, I'll get that angle C could be 49.8 degrees. And now, when I set up my law of sines, cross multiply and divide, I'll find that little c, 10.3. So here is triangle 1 with that given scenario, or triangle 2 with the same given scenario. Again, what makes this one difficult? Because SSA says if you are given this angle is acute, the given one, that's a red flag. Make sure you go look at the fact of, can you have two triangles or can you not have two triangles? All right, those are all our examples for the law of sines. Great job, guys.